Mercury, the closest planet to the Sun, is a world of extremes and mysteries. At first glance, it appears to be a barren, scorched wasteland, a place where the Sun's relentless heat dominates everything. But beneath its seemingly lifeless surface lies a treasure trove of geological wonders, bizarre landscapes, and scientific enigmas that continue to baffle astronomers and planetary scientists. Today, we're diving deep into Mercury's weirdest landscapes to uncover what's really going on with this enigmatic planet. From its mysterious hollows to its towering ridges, Mercury is a world that defies expectations and challenges our understanding of planetary formation and evolution. Let's start with the basics. Mercury is a small planet with a radius of just 1,516 miles, making it only slightly larger than Earth's moon. It orbits the Sun at an average distance of 36 million miles, completing a full orbit in just 88 Earth days. But here's where things get interesting. Mercury's day is incredibly long. It takes 59 Earth days for the planet to complete a single rotation on its axis. This means that a single day on Mercury lasts almost 2 months on Earth. Imagine living in a world where the sun rises, lingers in the sky for months, and then sets for an equally long night. This slow rotation, combined with its lack of a substantial atmosphere, creates extreme temperature variations. During the day, surface temperatures can soar to a blistering 800 degrees Fahrenheit, hot enough to melt lead. But at night, without an atmosphere to trap heat, temperatures plummet to a frigid minus 290 degrees Fahrenheit. It's a planet of extremes, where survival is impossible. And yet, it holds secrets that could rewrite our understanding of the solar system. One of the most striking features of Mercury is its heavily cratered surface. The planet is covered in impact craters, the result of billions of years of collisions with asteroids and comets. These craters tell the story of a violent past, a time when the inner solar system was a chaotic and dangerous place. But not all craters are created equal. Mercury's craters come in a variety of shapes and sizes, from small, simple pits to massive, complex basins. Some of these craters are so large that they dwarf anything found on Earth. Take, for example, the Caloris Basin, one of the largest impact craters in the solar system. This colossal crater measures a staggering 963 miles across, making it larger than the state of Texas. The impact that created Caloris was so powerful that it sent shockwaves across the planet, creating a region of chaotic terrain on the opposite side of Mercury. This chaotic terrain, known as the weird terrain, is a jumbled mess of hills and valleys, a testament to the sheer force of the collision. But Mercury's craters aren't just impressive for their size, they also hold clues about the planet's geological history. For instance, some craters have smooth, flat floors, suggesting that they were once filled with lava. This indicates that Mercury was volcanically active in the past, with molten rock flowing across its surface and filling in the low-lying areas. Other craters have bright rays radiating outward from their centers, a sign that they are relatively young. These rays are made of material ejected during the impact, and they gradually fade over time as they are bombarded by micrometeorites and solar radiation. By studying these craters, scientists can piece together the timeline of Mercury's geological activity, from its fiery volcanic past to its more quiescent present. While craters dominate Mercury's landscape, they aren't the only features worth noting. The planet is also home to a variety of other geological formations, including ridges, scarps, and hollows. One of the most intriguing of these features is the hollows. These are shallow, irregular depressions that dot the surface of Mercury, often found inside craters or on their rims. Unlike impact craters, which are formed by collisions, hollows are thought to be the result of volatile materials escaping from the planet's surface. When these materials, such as sulfur or other volatile compounds, are exposed to the sun's intense heat, they sublimate, leaving behind empty pits. Over time, these pits grow and merge, creating the hollows we see today. What's truly fascinating about these hollows is that they appear to be actively forming, suggesting that Mercury's surface is still evolving. This makes Mercury one of the few places in the solar system where we can witness geological processes in real time. Another peculiar feature of Mercury is its scarps or cliffs. These towering ridges can stretch for hundreds of miles and rise up to a mile high. They are thought to have formed as the planet's interior cooled and contracted, causing the crust to buckle and crack. Imagine the entire planet shrinking like a dried-up apple, its surface wrinkling and folding as it does so. These scarps are a testament to Mercury's dynamic past, a time when the planet was still cooling and settling into its current form. But they also raise questions about the planet's interior. How much of Mercury's core is still molten? What drives the planet's magnetic field, which, despite its small size, is surprisingly strong? These are questions that scientists are still working to answer. Speaking of Mercury's magnetic field, it's another one of the planet's many mysteries. Unlike Venus and Mars, which lack global magnetic fields, Mercury has a weak but detectable magnetic field. This field is generated by the motion of molten iron in the planet's core, much like Earth's magnetic field. But Mercury's core is unusually large, making up about 85% of the planet's radius. This raises the question, how did Mercury end up with such a large core? One theory is that the planet was once much larger, but a massive collision stripped away its outer layers, leaving behind a dense, metal-rich core. Another possibility is that Mercury formed closer to the Sun, where the intense heat vaporized much of its rocky mantle, leaving behind a core-dominated planet. Whatever the case, Mercury's magnetic field is a puzzle that continues to intrigue scientists. But perhaps the most surprising discovery about Mercury is the presence of water ice at its poles. Yes, you heard that right. Water ice on a planet where daytime temperatures can reach 800 degrees Fahrenheit. How is this possible? The answer lies in Mercury's unique geography. The planet's axis is almost perfectly perpendicular to its orbit, meaning that the poles receive very little sunlight. As a result, the floors of some craters near the poles are permanently shadowed, creating cold traps where temperatures can remain below minus 280 degrees Fahrenheit. In these frigid conditions, water ice can persist for billions of years. This discovery was made by NASA's Messenger spacecraft, which detected bright, radar-reflective regions in Mercury's polar craters. These regions are consistent with the presence of water ice, and subsequent observations have confirmed their existence. But where did this ice come from? One possibility is that it was delivered by comets and asteroids, which crashed into Mercury and deposited their water in the cold traps. Another possibility is that the water was outgassed from the planet's interior, a process that could still be ongoing today. Either way, the presence of water ice on Mercury is a reminder that even the most unlikely places in the solar system can hold surprises. As we continue to explore Mercury, we're learning more about its strange and fascinating landscapes. But there's still so much we don't know. What drives the planet's geological activity? How did its core become so large? And what other secrets are hidden beneath its surface? These are questions that future missions like the European Space Agency's Bepi Colombo hope to answer. Bepi Colombo, which launched in 2018, is set to arrive at Mercury in 2025. The mission consists of 2 spacecraft that will study the planet from orbit, providing new insights into its magnetic field, surface composition, and geological history. With its advanced instruments, Bepi Colombo will help us unravel the mysteries of Mercury and shed light on the processes that shaped this unique world. Mercury's story is far from over. As we delve deeper into its mysteries, we uncover more questions than answers, and each discovery paints a more complex picture of this enigmatic world. The planet's surface, though seemingly static, is a dynamic canvas shaped by forces both internal and external. From its shrinking core to its ever-changing hollows, Mercury is a testament to the incredible diversity and complexity of planetary evolution. But what else makes this tiny planet so fascinating? Let's explore further. One of the most intriguing aspects of Mercury is its magnetic field. For a planet so small and so close to the Sun, the presence of a magnetic field is unexpected. Earth's magnetic field is generated by the motion of molten iron in its outer core, a process known as the dynamo effect. Mercury, despite its small size, also has a magnetic field, albeit much weaker than Earth's. This suggests that Mercury's core is at least partially molten, a surprising fact given the planet's proximity to the Sun and the intense heat it experiences. Scientists believe that Mercury's core may contain lighter elements such as sulfur, which lower the melting point of the iron and keep it in a liquid state. This molten core, combined with the planet's relatively rapid rotation, generates the magnetic field that protects Mercury from the full force of the solar wind. But even this magnetic field has its quirks. Unlike Earth's symmetrical magnetic field, Mercury's is lopsided, with the magnetic North Pole shifted significantly toward the planet's equator. This asymmetry is another puzzle that scientists are eager to solve. Another fascinating feature of Mercury is a thin, tenuous layer of gases that barely qualifies as an atmosphere. Unlike Earth's thick atmosphere, which protects the surface from harmful radiation and regulates temperature, Mercury's exosphere is so thin that atoms rarely collide with one another. Instead, they follow ballistic trajectories, bouncing along the surface or escaping into space. The exosphere is composed of a variety of elements, including hydrogen, helium, oxygen, sodium, potassium, and calcium. These elements are thought to come from a combination of sources, including the solar wind, micrometeorite impacts, and outgassing from the planet's interior. The presence of sodium and potassium in particular is intriguing because these elements are highly volatile and would typically be lost to space over time. Their persistence in Mercury's exosphere suggests that there may be ongoing processes replenishing them, such as the sublimation of surface materials or the release of gases from the planet's interior. Mercury's exosphere also plays a role in one of its most mysterious phenomena. Observations from Earth have revealed that Mercury has a long, comet-like tail of sodium atoms that extends millions of miles into space. This tail is created when solar radiation pushes sodium atoms from the planet's exosphere into space, forming a glowing trail that can be seen from Earth. The tail is not constant. It varies in brightness and length, depending on Mercury's position in its orbit and the activity of the Sun. During periods of high solar activity, the tail can become particularly bright and elongated, creating a stunning visual display. This transient tail is a reminder of the dynamic interplay between Mercury and its environment, a dance of particles and radiation that shapes the planet's tenuous atmosphere. But perhaps the most captivating aspect of Mercury, despite its small size and proximity to the Sun, Mercury is not a dead world. The planet's surface is constantly changing, shaped by a combination of impacts, volcanic activity, and the loss of volatile materials. One of the most striking examples of this ongoing activity is the formation. These shallow, irregular depressions are found across Mercury's surface, often clustered in and around impact craters. Unlike impact craters, which are formed by collisions, hollows are thought to be the result of volatile materials escaping from the planet's surface. When these materials, such as sulfur or other volatile compounds, are exposed to the Sun's intense heat, they sublimate, leaving behind empty pits. Over time, these pits grow and merge, creating the hollows we see today. What's truly fascinating about these hollows is that they appear to be actively forming, suggesting that Mercury's surface is still evolving. This makes Mercury one of the few places in the solar system where we can witness geological processes in real time. The presence of hollows also raises questions about the composition of Mercury's surface. Scientists believe that the planet's crust may contain significant amounts of volatile materials such as sulfur, chlorine, and sodium. These materials are typically lost during the early stages of planetary formation, but Mercury's unique history may have allowed them to persist. One theory is that Mercury formed closer to the Sun, where the intense heat vaporized much of its rocky mantle, leaving behind a core-dominated planet with a crust rich in volatile elements. Another possibility is that Mercury's surface was bombarded by volatile-rich comets and asteroids, which deposited these materials on the planet's surface. Whatever the case, the presence of volatile materials on Mercury is a reminder of the planet's complex and dynamic history. As we continue to explore Mercury, we're also learning more about its. Despite its small size, Mercury has a surprisingly large core, which makes up about 85% of the planet's radius. This core is thought to be partially molten, generating the planet's magnetic field and driving its geological activity. But the exact composition and structure of Mercury's core remain a mystery. Scientists believe that the core may contain lighter elements such as sulfur, which lower the melting point of the iron and keep it in a liquid state. This molten core, combined with the planet's relatively rapid rotation, generates the magnetic field that protects Mercury from the full force of the solar wind. But even this magnetic field has its quirks. Unlike Earth's symmetrical magnetic field, Mercury's is lopsided, with the magnetic North Pole shifted significantly toward the planet's equator. This asymmetry is another puzzle that scientists are eager to solve. Mercury's interior is also thought to be the source of its battle, tectonic activity. The planet's surface is covered in lobate scarps, towering cliffs that can stretch for hundreds of miles and rise up to a mile high. These scarps are thought to have formed as the planet's interior cooled and contracted, causing the crust to buckle and crack. Imagine the entire planet shrinking like a dried-up apple, its surface wrinkling and folding as it does so. These scarps are a testament to Mercury's dynamic past, a time when the planet was still cooling and settling into its current form. But they also raise questions about the planet's interior. How much of Mercury's core is still molten? What drives the planet's magnetic field, which, despite its small size, is surprisingly strong? These are questions that scientists are still working to answer. As we look to the future, the exploration of Mercury promises to reveal even more about this fascinating world. The Sovic Bepi-Colombo mission, a joint effort by the European Space Agency and the Japan Aerospace Exploration Agency, is set to arrive at Mercury in 2025. This mission consists of 2 spacecraft that will study the planet from orbit, providing new insights into its magnetic field, surface composition, and geological history. With its advanced instruments, Bepi-Colombo will help us unravel the mysteries of Mercury and shed light on the processes that shaped this unique world. Mercury, the smallest and innermost planet of our solar system, is a world that defies imagination. It's a place where the sun looms large in the sky, appearing 3 times bigger than it does from Earth, casting an intense, unrelenting glare over a landscape that seems both alien and eerily familiar. This tiny planet, often overlooked in favor of its more glamorous neighbors, holds secrets that stir the soul and ignite the imagination. It's a world of paradoxes, scorching yet icy, ancient yet dynamic, barren yet brimming with mysteries. As we peel back the layers of Mercury's story, we uncover a tale of cosmic violence, resilience, and beauty that resonates deeply with our own human quest for understanding. Imagine standing on the surface of Mercury, feeling the ground beneath your feet, a ground that has witnessed the birth of the solar system and endured billions of years of relentless bombardment. The sun, a blazing orb of fire, hangs motionless in the sky, its light so intense that it casts sharp, black shadows across the rugged terrain. The airless silence is deafening, broken only by the occasional whisper of solar wind particles brushing against the planet's surface. You look around and see a landscape that is both haunting and beautiful, a mosaic of craters, ridges, and plains that tell the story of a planet shaped by unimaginable forces. This is Mercury, a world that has survived the chaos of the early solar system and emerged as a testament to the enduring power of nature. One of the most emotional aspects of Mercury's story is its resilience. Despite its proximity to the sun and the constant barrage of solar radiation, Mercury has managed to hold on to its identity. It has a magnetic field, a tenuous exosphere, and even water ice at its poles, features that seem almost miraculous given the planet's harsh environment. These remnants of Mercury's past are like whispers from a distant time, reminding us that even in the most hostile conditions, life, or at least the potential for it, can persist. The discovery of water ice on Mercury, hidden in the shadows of its polar craters, is particularly poignant. It's a reminder that even in the darkest, coldest corners of the universe, there is hope. It's a symbol of resilience, a testament to the enduring power of nature to find a way even in the face of overwhelming odds. But Mercury's story is not just one of survival, it's also a story of transformation. The planet's surface is a living record of its journey through time, a canvas that has been painted and repainted by the forces of nature. The craters that dot its surface are like scars, each one telling the story of a violent collision that shaped the planet's destiny. The ridges and scarps that crisscross its surface are like wrinkles, evidence of a planet that has aged and shrunk over billions of years. And the hollows, those strange, shimmering depressions that seem to glow in the sunlight, are like open wounds, reminders that Mercury's story is still being written. These features are not just geological formations, they are symbols of the planet's journey, a journey that mirrors our own in so many ways. As we explore Mercury, we can't help but feel a sense of awe and wonder. This tiny planet, so close to the Sun, and yet so full of surprises, challenges our understanding of the universe and our place in it. It reminds us that even the smallest, most unassuming worlds can hold secrets that change the way we see ourselves and our cosmos. Mercury's story is a reminder that the universe is full of surprises, that there is always more to discover, and that even in the most unlikely places, there is beauty and mystery waiting to be uncovered. And then there's the emotional connection we feel to Mercury, a connection that goes beyond science and exploration. This planet, with its stark beauty and haunting landscapes, speaks to something deep within us. It's a reminder of our own fragility, our own resilience, and our own capacity for wonder. When we look at Mercury, we see a world that has endured unimaginable challenges and emerged stronger for it. We see a world that, despite its harsh environment, holds on to the hope of water and the promise of discovery. And we see a world that, in its own quiet way, reminds us of the beauty and mystery of the universe. As we continue to explore Mercury, we are not just uncovering the secrets of a distant world, we are uncovering the secrets of ourselves. Every crater, every ridge, every hollow is a piece of the puzzle, a clue that helps us understand our place in the cosmos. And as we piece together the story of Mercury, we are reminded of the power of curiosity, the importance of resilience, and the beauty of discovery. Mercury may be a small planet, but its story is anything but small. It's a story of survival, transformation, and hope, a story that resonates deeply with our own human experience.